Hello everyone. So this is a one shot video on natural language processing. So here is the checklist of what we are going to learn throughout this video. So please stay till the end of this video so that you get to learn a lot. So first we will start with the basics. We will do pip install NLTK. So in case if you don't have the Python Jupyter notebook yet, you are requested to see my description where I have in detail explained how to install pip, how to install Python Jupyter notebook in your VS Code. So you can just simply do pip install NLTK. So this would take some time to execute, and this nltk.download all you need to execute this. So first of all, this pip install nltk you can also do in the command prompt or in the terminal of VS Code itself. So now let's get to this sample text. Suppose we assign some variable sample text which contains this string. So first let me uh, try to make you understand what exactly do we mean when we say natural language processing. So in one of our previous project we created something known as that word some analysis of text documents and all. We used each word as our feature in that text analysis. We basically tried to predict what topic is being talked about in all those documents. So we will do, so that is basically the essence of natural language processing. We will do the same thing here, but we will use some few things which have more sense in it. So basically there will be speeches and we need to analyze those speeches, that what sentiment those speeches contain. And suppose we have some reviews, suppose someone has given a review about a movie, so whether it is a positive review or a negative review, our machine should be able to predict those using the language which has been written there. So that's the purpose of natural language processing. So let's just check out how to analyze word by word and each sentence like this. So here you can see in this sample text we have two sentences. Does this thing really work? Let's see. So there is something called tokenize. From nltk.tokenize import send tokenize and word tokenize. So what we did during our text classifier stuff, we create first. I would suggest you to watch my video on text classifier. So I have clearly explained that there, and the same thing we are doing here, but with a bit smarter approach with new algorithms. So you can always do split this sample text dot split space. It will make all the space separated words to contain in a list. So what we do here, so that is known as basically word tokenize. Send tokenize will separate the sentences, word tokenize will separate each word. So we are basically going to use each word as our feature. So here, so we need to separate out each of them. So using word tokenize and send tokenize, these are easily done. So now you know there is something known as stop words. I also explained in my text classifier video that this stop word are the English words which are used very frequently, whose frequency would be high in a given document, and we need to remove those. For example, so see what is our sole motive of this natural language processing. There would be some document and there would be some speeches from which we need to analyze the sentiment, or we would like to predict what is being talked about in that document, what is being talked about in that article. So there are some words known as stuff like this, that, then maybe a and the, and maybe full stop, or maybe an exclamation mark, or maybe question mark. So those are basically of no use to us in predicting what is being talked about in the document. For example, the word this is used multiple times in a document. Suppose the frequency of the word this is very high. Can you predict anything? What exactly will be, what is exactly is being talked about in that document? So we cannot predict. So such kinds of words are known as stop words. So what we did in our text classifier video was that we searched the website, or we searched the internet to find out all the possible English stop words. But from here, NLTK, natural language processing. So NLTK is basically the library which is used for natural language processing, the inbuilt library of sklearn, not from sklearn, the inbuilt library for natural language processing in Python. So from something known as corpus module, we can import this stop words. So stop equals to words of English. So you can see these are all the stop words. You can notice each word says nothing about what is being talked about in a particular document. It would say nothing about that. So we consider all these as stop words, and then we import string, and we also concatenate, means increase. This is a list of words, list of stop words basically. So list of strings. So we also concatenate this list with the list of punctuations, because those are also of no use in our sentiment analysis or in predicting what is being talked about in our document. So what we do now, we create for w in words if w not in stop. So this I have used list comprehension. You can also do it the traditional way of for loop, like for you can also write a for loop this way, that for w in words if w not in stop, clean words dot append w. So you can also do this, but this is much shorter. So w for w in words if w not in stop. You can also check this out in the internet for a better understanding. This is the same thing of this basically. So this is known as list comprehension. I have already explained this in earlier videos. So these are the clean words. Now you see we these when we initially did word tokenize, we had does, we had this, we had question mark, we have this full stop, but now only we have only the important words. Thing really works, let's see, we would use this as features. So this way we can clean our words. And now there is something known as stemming. So also in my text classifier video, we worked on a project. We did the same thing basically, but we didn't take care of the stuffs like adjectives and adverbs of a single word. For example, a single word play can be used as a noun in playing. So it can be used as played. So suppose these all things are there, these all words are there in a document. Do they mean anything different? You might say that maybe the document is being talked about is sports, the document or the article from where these words are, that article is related to sports. So this word play has a lot of information, but does playing and play have different meaning? Something with respect to our features, they all actually mean the same when we see from the point of view of our features to be fed into our model. So we use something known as Porter streamer. So what it does basically is it will first we create an object handle, then we do object.stem of I for I in stem words. So for I in stem words, we create another list known as stemmed words. So here play, playing and played, these are all noun forms or verbs forms, are converted into the root word play, and this player is might mean something different from play, so it's kept the same. But one thing you need to understand here clearly is, and you need to be cautious also while using this. Suppose we use something like briefly. So what does it output? See, it thought that the root word is briefly, which makes no sense. So what do we understand from this example? This example says that this Potter stemmer has no knowledge of English dictionary. It does not understand whether our final word is there in the dictionary or not. So of course, briefly, you would not like to convert it to brief, obviously. So you need to take care of what exactly you are entering in our Potter stemmer object handle. So you need to take care of that. So from NLT, now we talk about pause tag, position tag basically. So to handle this kind of anomaly, we will discuss further how to do this. So we use some modules from NLTK import pause tag, and from NLTK.corpus import state union. So what is this state union? This is a basically speech said by George Bush in 2016. President George W. Bush address before the joint session of the Congress on the State of Union. So this is his speech, whose text we get from here. So this is his long speech. So we might need to do the language processing of this speech. So yeah, that's help. You can also find out what exactly is this pause tag. So what it does is, first it takes a list of words. For example, first of all, pause tag will take a list of words, and now it will give out some output. Now this pause tag list of words we can easily get from word tokenize. Now this pause tag will give a list of tuples, and the second element of those tuples will be what exactly is. Suppose NNP means pronoun, not pronoun, noun used as a first person, something like that, personal noun or something like that, proper noun basically, proper noun. NNP means proper noun. You can see President George Bush, everything is proper noun. So you can find out what each of the full form means. So if J something means adjective, and you can also check out what the other full forms mean. So now yeah, you can also maybe explore this help where things might be told, like yeah, so you can see here bad is JJ, which is adjective, idea is NN, which is noun. So it means that JJ stands for adjective, NN stands for noun. Similarly, VBZ stands for verb. So you can check this out to find out what each of those short forms stand for. So we now have our position tag applied on a variable. Now we have this list of tuples. So now what we are going to do is, yeah, so this is a small example of what is actually happening above. So Raj went for a walk. So this Raj is proper noun, went is verb, for is here, I think in what it may be. You can just check those out. Yeah, so this is just an example. So from nltk.stem, now you can import this word net lematizer. This lematizer does actually what? So there was an anomaly here that briefly has no meaning, but still it is being converted. So this word net lematizer helps us in dealing with those anomalies. This we will use suppose better, and we give pause equals to, we are lemmatizing the word better, we are finding the root word of that, and we are saying a is of, I guess, verb, or yeah. So you, what you want to convert to, a is the thing what you want to convert to. For example, this painting is a noun which you want to convert it to a verb, so the output will be paint. Similarly, if painting you want to convert it to noun, so it will remain the same painting. Similarly, this is basically, and a stands for adverb, so a stands for adjective, sorry, a would stand for adjective here, because yeah, this is comparative degree of adjective. So you are converting better to the root word of the adjective, so we would get the output as good. So now let us check out, these are the basic knowledge of natural language processing. So we have just reached till lemmatizing, so we have to do these stuffs. So let us take a movie review data set. There is a data set where there are documents. Each of the documents have a review given by one person about a movie, and our machine learning model need to predict what our that our movie review uh, is exactly what is a positive review or is a negative review or what. So we are doing basically sentiment analysis using NLP. So we import NLTK, or we can just import from nltk.corpus import movie reviews. Now there are these are categories: negative reviews and positive reviews. So only two in the list. Now movie reviews dot field IDs will give us all the IDs of the field in a list. So each of these field IDs is a document, text document. You can see the .txt stands for text document. So now what is the length of all these field IDs is 2000. You can get through this. Now you see movie reviews dot words, movie review dot field IDs. So what was field IDs actually? What exactly was field ID? It was a list of IDs. So we just take the first document. So this 0 means we are taking the first element of that list. So we now have this first element means this thing, this string. Now this document, if we do movie reviews dot words, we will get all the words of those document in a list, lemmatized form. So we don't need to use the lemmatizer here. But if a real life data you are analyzing from any article, you need to use that lemmatizer. So here in this movie review dataset, we already have these words lemmatized. Now what we are going to do is we are going to do this. We would make our data ready to use by a sklearn algorithm. So what is our ultimate motive? We would apply something known as like maybe support vector machines. We are trying to classify, right? So maybe support vector machines, we will maybe applying uh, the logistic regression, or maybe we will apply the random forest regress classifier. So yeah, we would basically be requiring a certain format which sklearn algorithms are would be easily acceptable by the sklearn algorithms. So such kind of format basically we need to design. So this document should contain such kind of format. So for category in movie reviews dot categories, so we had two categories, so we are iterating only the two element of the list. And then for field id in movie reviews dot field id, so we had the list of field id, we are traversing through the field IDs as well as the category. Now we do document dot append movie reviews of field id words and the category. So now our document, let's say from 0 to 5, so maybe the first 5 documents we are trying to view. So this is something what we obtain. The list contains a tuple, list of tuples it is basically, and that tuple will contain the first element as the list of words and the second element as the review category, whether it is a positive review or a negative review. So yeah, we during our training phase also we have our output y, and these are all the x values, the features. So yeah, see, still we are doing the supervised learning. So what we do is to not to make our algorithm or make our maybe the sklearn algorithm some, so we don't need to add any kind of biasness towards our data. So we just shuffled using a random dot shuffle. So here you see first there are negative views and then at the end maybe there are positive views, so we just shuffle those. Now we have stuffs in a shuffled form, some are positive, some are negative. Yeah, so what we do next is the word net limitizer. Now from nltk.corpus we import something known as word net. Now we create a definition function. So this function, if this will take a word, maybe it will take a tag which will be a string. If that string starts with j, I told you there are stuffs like JJ stands for adjective, NN stands for common noun, NNP stands for proper noun, and stuff. So whatever the thing, if it starts with J, it has to be adjective. So I'm returning the. So what get simple pause tag will do, it will take the tag and it will say what this tag is of. Is this tag is of an adjective, is this tag is of a verb, or it is a noun, or it is an adverb. Okay, so if it is nothing, it has to be a noun. So just we assign this. If we can't understand what it is, so it would be a noun. Let's just assume that. And we also get rid of the stop words. From nltk.corpus we import stop words, and the stop words of words English, we will get all the stop words plus list of all those punctuations will be our total stop words. Now the same thing we are going to import what I showed you about pause tag in the previous notebook, this. So yeah, this clean review, we create another function. This clean review of words will take all the words and will give some output of words. So for w in words, it will be iterating through each of the words. If w.lower not in stop, so we are basically not we will basically the output words would not contain any stop words. This if clause ensures that. And this pause tag of w, so pause tag takes a list of words. I told you what pause tag takes in this earlier explained. I explained you, still I am revisiting. This pause tags takes a list of words because word tokenize will convert them to a list of words, and then it will return a list of tuples with the second element being the tag. So this pause tag will take a list of words. So we have only word, so we convert that to a list of single element, and we just try to get a tuple from them. So this clean word will be lematizer.lematize w get simple pause of pause 01. So what exactly happened here we need to understand. What does get simple pause takes? It takes the pause, it takes the tag and tells what is it, adverb or noun or what. It just specifies that. So if you see, this pause of 0 is what? Is the first, is the tuple which it returned. Pause tag returns a tuple, right? That, so, and this word is a list of tuples. So pause of 0 will be the first tuple in my list, and pause of 0 of 1 will be the second element of that my tuple. 1, because it is 1, so it will be the second element of my tuple. So what is the second element of my tuple? First tuple. My second element is this. You can easily see that. And if this second element, we just take our second element and input in the lematize. So in the lematizer also I showed that pause may be standing for A for adverb. So instead of this A, you can also give the entire pause. Maybe instead of V, you are giving VBZ, and instead of noun, maybe you are giving NNP or NN something. So you are just lemmatizing each of those words. So our output words now contains, we can just append those. Clean of lower, you can just lower the word. This lower is for lowercase. So yeah, you have the output words from a given set of input words. So now what you are doing is you are importing time, and this is basically to calculate how much time it requires to clean the data. So clean review, we just do clean review. We created this function clean review dot get document of document dot comma category for document comma category in document. So again I am using here list comprehension for some short. So this cleaning time is something which is 18 minutes 34.8 seconds. So yeah, it would take some time. That's why I've run this code earlier for you. So what does our document of 0 contains? Basically it is the first document. So it will contain a list of words with a tuple. Basically the first element of the tuple is the list of words, and the second element is this pause. So yeah, now my documents contains something like this. Now my document is really clean because I have lemmatized my documents. I have removed all the stop words from my documents. I have tokenized my documents. So yeah, my document is really clean now. Now just get to the form of that sklearn thing which we were talking about. Just let us make it ready to use by any sklearn algorithm. So the training documents we will be taking as, let's say, out of 2000 we are taking 3/4, so 0 to 1500. So and 1500 to remaining, that remaining testing documents. Now all of the words we can store in a single list using this. And then doc of 0 is what? Doc of 0 is basically the list of words. So for doc in documents, so doc of 0 is basically the list of words, because it is a tuple, right, where the first element is a list. So doc of 0 is the list of words, and we just keep all our words in a single list. Now we do something known as frequency distribution. So what we are going to do is we would select our word with the maximum frequency, and we will use that word to give the maximum weightage to what exactly is being talked about in that document. So if we just do frequency distribution, we can easily get the frequency of each word. So it basically returns a frequency distribution object, and suppose we want the most common 3000 words. Tell me the most common 3000 words. So yeah, so some words which are of very low frequency, like one frequency, maybe one word is used one time in a document, but that word those kinds of words do not matter much to us. So we will take the most common 3000 words and store it in a variable called common. Now I of 0 for I in common. So these are our features which we are going to use. So what does common contains? From this frequency distribution object, this common contains this list of tuples. Each tuple in turn has the word and how many frequency, what is the frequency of that word. So all of these are in descending order. So most common 3000 words we select as our features. Now we will get our feature dictionary. So we have our words now. We will get the feature dictionary. So what are we basically trying to do is we create an empty dictionary, and then word set, we create the set of words. Set of words basically will give that same thing, all the words and its frequency. Now for W in words, if current features of W equals to words in set. So this is what? This is a true or false value, right? In is a membership operation which tells us whether if W is present in the words set, and for W in features, so what it is exactly doing is we are going through each feature set. So we will be going through each of the documents in our testing phase, yeah, and our training phase also. So our current document contains these many current features, and this is this all the set of words which we have. Now out of all the set of words, if our features, if our given features, the top 3000 features is, if it is there, then our current features will be something like this. Yeah, you clearly understand this, right? What we are doing is, first we are creating an empty dictionary. That dictionary will contains only the current features. First, now as of now we have only those as our features, that is most common in terms of frequency, the top 3000 words. Yeah, we are having those as our features, but all those 3000 words do not contain in the may not contain in the document which we are analyzing currently. So currently the document which we are analyzing would contain only those words which are there in this current features dictionary. So yeah, I explained it quite in a detailed way. So now the training data we can get to make it sklearn ready. We will just get features dictionary doc comma category for doc comma category in training documents. So yeah, this way we can create the training and the testing documents. Now suppose we will try out new algorithms, maybe naive Bayes classifier. So from NLTK we can import naive Bayes classifier. We can import from sklearn also, there's no problem. So classifier, naive Bayes classifier training data. This will give us our accuracy, and this will also give us what is our most important feature. So maybe ludicrous, this word. So this word, if it is true, then the negative to positive ratio in my document is 12.2:1. So this anger, if it is anger, this word is true, then maybe my word is mostly positive. Maybe my document is mostly positive. So these may not be always true, but what these words are basically most informative. If these words is present, then being positive of a document is 8.6 times more than being negative. It basically says this. Yeah. So now we use sklearn classifiers in NLTK. Let's say use support vector machine. So do classifier sklearn of SVC, and then classifier sklearn.train of training data, and then we can easily get the accuracy. We can check out different models You can just check out the random forest classifier. So let us just create an object handle and let us just train our training data and then check out what accuracy we get. What accuracy does our model get? It is 80.2% accurate. So now we come to something known as count vectorizer. So from sklearn.featureSelection.text we import count vectorizer. Now what is this? It will give us a sparse matrix which gives us information about the most frequent words. So I say that take the max features as 3, count vectorizer my object handle, count vec takes the max feature as 3. So what it does now is it will see the frequency of each word in the entire list. The frequency of the word the is 2 times, the frequency of sky is also 2 times, the frequency of is also 2 times. So these are the top 3 features. Now in our first sentence, maybe if we do just count vectorizers or feature names, we will get the features with highest frequency. It is sky the. Now is present in the first document how many times? 1 time, so we have 1 here. Is present in the second document how many times? 1 time, so we have 1 in the down as well. The word sky is present in the first document 2 times, whereas second documents 0, so we have 2 and 0 respectively. And similarly for the. So this count vectorizers basically returns this sparse matrix. Now we are doing this for the train test split basically. So for category documents, comma category in documents, we just separate out all our categories and text documents together. Now from sklearn.model selection we import train test split. Now we just create our xtest y-test using this train test split. Now this count vectorizer, let's say it takes the max features as 2000, so I'm using the count vectorizer thing here. Before that I explained you with a simple example of what this count vectorizer actually does, so that you don't get confused when I directly apply in this entire document. So you now easily know what exactly is happening here in this matrix. So yeah, these are the top feature names, these are the top k features. Now this xtest features can be used to transform the xtest values. So it just count vectorizer basically just transforms. So it is a sparse matrix of type numpy array. So yeah, this we can use for our further analysis. So now we have something known as n-gram. So actually this count vectorizer has some more arguments which we will talk about. So first, this n-gram is an n token sequence of words. Suppose a 2 gram is known as bigram, a 2-word sequence of words like really good, not good, your homework, and a 3 gram 3 sequence of words. Yeah, so this is the maximum and the minimum sequence of words which we want. We will give that as in our n-gram range. So now if we do this, what we will get basically is get the feature names. Our features to be used in our model will be 2 word. All will be 2 word. We were using each word as our feature, now we will use a pair of word as our feature. Now we can feed this into, we can just convert it into our model and then see what is the accuracy for this. Now there are more arguments, min df and max df. So when we are using these arguments as float, they refer to document frequency, that is the percentage of documents that contains the term. So yeah, if we have suppose 5 text files, if you set the maximum df to 0.6, then that would translate to 0.6 into 5, so 3 documents. So yeah, and when we use it at integer, it refers to the absolute number of documents that we would like to hold this term. So count vectorizer just checks whether this min df is, let's say, 1. So the word has to, our reference word, the word which we are iterating through, has to be present in at least 10% of the document, and it can be present in at most 70% of the document. Then that word we will use for our count vectorizer, and basically that is the word which we will use for determining our data set. So those are the words we will use to feed our machine learning model. So we have our xtest features as count vector dot transform. Now from sklearn we can import svc. So as it will be as not scv, it will be svc. Now we can just do fit and we will see the xtest feature and the xy test. This is the format which svc takes for calculating the score. So we'll get this score. Now there is also one last concept of tf-idf. You can apply this on your own. So it is an abbreviation for term frequency and inverse document frequency. This is a very common algorithm to transform text into a meaningful representation of numbers. So what we will do basically is we will take two terms and multiply those and use that as a final metric for accuracy. So the term frequency of a word in a document, TF, is simply that. There are several ways of calculating this frequency, with the simple being the raw count of instances of the word appears in a document. Then there are ways to adjust the frequency by length of the document or by raw frequency of the most frequent word in the document. Now the inverse document frequency of the word is across the whole set of documents. We have to see the entire set of documents. We will just take the total number of documents divided by the number of documents that contains the word, and so the maximum it can go is till 1, because our numerator is the maximum value and the denominator is always the least value it can go till is 1, because the total number of documents is in our numerator and the number of documents that contains the word is in the denominator, so it will always be greater than 1 if we take the logarithm. So yeah, the closer it will be to 0, the more common the word is, because the more common the word is, the closer the fraction will be towards 1, and this score will go towards 0 because we calculate the logarithm. So we basically take these two words, these two terms, the term frequency and the inverse document frequency, and we multiply these two numbers, results in the TF-IDF score of a word in a document. The higher the score, the more relevant the word is in that particular document. So you can do one thing is that you can calculate the TF-IDF score for each word in the document and then repeat all over the same process what we did and then feed it to one of our machine learning model to see if our processing the words improves or not. So yeah, this was the last concept we had. So yeah, we are more or less done with all the overall concepts. Now you can just keep on applying these concepts one by one. So there can be Twitter sentiment analysis also. I have done here the movie review analysis. So yeah, that's all from this video. Meet you in the next video. Till then, thanks a lot.